Hello students. So we'll start now the next chapter of your computer science. This is chapter number 6. We see that says study of components and circuits. You see the components and circuits, whatever the course contains, they are very basic concepts are given, but detailed study of these components and semiconductor circuits we'll see in your next class, in your class 12 on computer science syllabus. So here we will go through all the contents and all the elementary information on these components. Okay, let us go. So electronic components, what are the components used in your computer or any electronic devices? Their basic components are two categories. One is your passive components, one active components. So the two category, one is passive components, second is active components. Now in passive components, what we'll study are resistors, capacitors and inductors. These three will see in your passive components. In active components, we will see mainly semiconductor devices. What are the semiconductor devices? They are the active components, and passive components by resistors, capacitors and inductors. Okay. Now first we will see resistors. What is resistors? Resistors means that gives you resistance in current supply. That is they are resistors. Electronics components which offer resistance are called resistors. Okay, it looks like this. These are resistance. These are two pole of the resistance, and it can be represented like this symbol. Here the resistors. Resistance is measured in ohms. Resistors are of fixed or variable types. Fixed resistors are made from carbon clay composition. Fixed resistors value are from 0 to 100 mega ohms. Okay. Let's see the next. Resistors. You see, resistor looks like this. It's color coded. There are symbols. Color coding is there. That tells about the characteristics of your resistors. Color coding system is used to indicate value of the resistor. Resistor का कितना value है, वो इसके ऊपर कितने ohms का है, that इसमें एक color से पता चलता है. Color codes are read from left to right. This side to this side you have to read it. First and second band represents first and second significant digit of resistance value. These two first two band they represent the first and second digit of resistance value. Suppose your first is red, second is yellow, so it will be 24. Okay. The next first and second band represents the first and second significant digit of the resistance value. Third band indicates the number of zeros that follow the digit. So it is, suppose it is red and now it is red and black. So 2 and 0, 20. The next color will tell you that, suppose next color is something like red again, it is I think yellow. So it will be 10 to the power 4 ohms. This way, this value of the resistor can be computed. Variable resistors are used to adjust values of current and voltage in an electronic circuit. This is the symbol. This comes in the symbol. It shows that this is a variable resistors. Variable resistors are called rheostat or potentiometer. जो दूसरा नाम भी है, it's called potentiometer. This is all about the resistors. Now you see the capacitor. What is capacitor? Now capacitors is meant for capacitor is meant for store electrons and release them whenever required. This is a capacitor. It looks like this. This is one plate. This is another plate. Which में some dielectric है. I mean some insulator is there. So it stores an electron. Whenever required, it releases the electron. Capacitor's value is measured in farad or microfarads. This is the symbol mu f. Mu f is nothing but 10 to the minus 6 farad or picofarad. और भी छोटा है. It is written like this. 10 to the minus 12 farad is picofarads. Capacitor consists of two conducting plates. These are the plates separated by insulating material. इसमें कुछ insulating material रहता है, known as dielectric. Two types of capacitor are there. One is fixed capacitor, one is variable capacitor. Okay, this capacitor looks like this. There are the two plates. The terminals are added to that. In बीच में insulator है. See, now this is mica capacitor and this is ceramic capacitor. How it is prepared? It looks like this. Capacitor looks like this, and in ceramic it looks like this. इसमें क्या? It is a foil है, metal foil है, बीच पे mica है. So this way, these capacitors are manufactured, and symbolically we write like this. Here also there are two plates are there. बीच में यहाँ पे माइको इंसुलेटर था, यहाँ पे सिरेमिक इंसुलेटर. माइका था, यहाँ पे सिरेमिक इंसुलेटर है. The other two plates. So capacitor nothing but two plates with a insulator in between. It looks like this. Now paper capacitor are there, where paper is there as an insulator. Paper capacitors from capacitance from 0.0005 microfarad to several microfarad and rated from 100 volt to several thousand volts. Okay. Next is electrolyte capacitor. Capacitance from 1 microfarad to several thousand microfarads and voltage rating from 1 volt to 500 volt or more. Variable capacitors are there. It is all are fixed capacitor. This is a variable capacitor is air gun capacitors is variable capacitor. Air is used here as dielectric substance. वहाँ जैसे आपने देखा that in your ceramic capacitor, the insulator is ceramic. Ceramic is used as an insulator. In air capacitor, variable capacitor, air is used in variable capacitor. Air is used as a dielectric substance. Okay, let's say next. You see, these are the capacitor looks like this. This is the capacitor. This is the capacitor. This is the capacitor. These all are capacitor. If you see, if you open the motherboard of a computer, you can see so many capacitors are there. what it does, it is stores electrons and releases whenever it is asked to release. Okay, we'll go to the next. Now this is inductor. These all are your resistor, capacitor, inductor. These all are passive components, passive electronic component, and semiconductor you'll see as active components. These are all passive components. Inductor, what is inductor? This is inductor. Inductor क्या है? There is a, on rod is there, and on coil is moving around the rod. Coil is created. This is a coil. So it is a electronic component that stores energy in a magnetic field. You see, in capacitor we have seen, it stores energy in electric form, current form. But here it is energy stored in magnetic field. You see, if you supply current here, the magnetic field will be generated outside. Okay. So by that field, the energy generated, that the energy is stored, that is called inductor. It is a electron component that stores energy in magnetic field. Magnetic field is generated by current flow over a coiled wire. This is a coiled wire. When current discontinues, the magnetic field magnetic field tries to flow the current at a steady rate. This is something is wrong here. When current flows, when current supplies, the magnetic field is created. When current discontinues, the current will be that magnetic field will continue supplying the current. That is the characteristic of inductor. Such a reaction of magnetic field is called induction, and the electron component is called inductor. In an inductor, there is a coil field is there. When current is supplied here, magnetic field is developed, magnetic field is created, and when supply discontinue, the magnetic field tries to supply the current continuously. The reaction of the magnetic field is called induction, and the electronic component is called inductor. Iron core inductor has an iron core placed inside the coil. For example, suppose it is an iron core inductor, which must be iron. Okay. The induction is measured in henries. Choke used in tube light is an example of inductor. You have seen the tube light, use the choke we use. That is an example of the uses of an inductor. This is another use of inductor is transformer. This transformer is what? This is the same material. The two inductors are generated. Two inductors are placed. That means this is one side, this is the other side. So we have two inductors. Transformer consists two inductors having the same core. The core is same. It may be iron, steel, anyway, whatever it may be, both are the same core. One inductor is called primary, other is secondary. This is suppose is a primary, naturally this is the secondary inductor. Induced voltage appears in the secondary when an AC is supplied in the primary. When you supply AC here, AC current you supply here, because of the magnetic field it generates, यहाँ पे भी current induce होता है, यहाँ पे voltage induce होता है, current supply होता है. So whatever voltage you given, same voltage is generated here, induced here. If your number of coils are, turning of the coils are same in both places. So the ratio, turning ratio, transformer turns ratio is the number of turns of coil in the primary to the number of turns in the secondary. कितना बार आपने इसको तार को घुमाया, यहाँ पे कितना घुमाया, उसको जो रेशियो है उसको बोलते हैं टर्न्स रेशियो ऑफ द ट्रांसफार्मर. ना सपोज यहाँ पे टर्निंग 10 है, यहाँ पे 5 है, दैट मीन्स टर्निंग रेशियो इज 10/5, दैट मीन्स 2. So that means 2 means more than 1. So when the ratio is more than 1, then the voltage generated here will be less. That's why it is called step down transformer. In step down transformer, the primary winding will be more than your secondary winding. But in other way, suppose it is 10 windings there in primary, in inductors, the secondary में 20 है, the ratio is 1/2, less than 1. So if this type of यहाँ पे ज़्यादा है, that's why it is called step up transformer. So step up transformer, step down transformer depends on the turns ratio of a transformer. Microwave transformer is set up, is a step up transformer with secondary voltage about 2200 volt. You may be knowing that microwave what you are using at your kitchen, that is a step up transformer, because it needs a lot of high voltage. It generates 2200 volt, whereas input is, we know, that's 230 volt or 220 volts. That is why it is a step up transformer. So this is an example of your microwave transformer. This is your secondary inductor, this is the primary inductor. So यहाँ पे ज़्यादा है वाइंडिंग, यहाँ पे कम है. Okay, now so what we have studied till now are resistors, we have seen the capacitors, we have seen the inductors. And inductors का हमने वो भी देखा, how the transformer is developed using inductors. Now we see the active components of active electronic components. Basically we will go through the semiconductor devices. Now what is semiconductor? Semiconductor is not insulator, not a good conductor. In between material, they are semiconductors. Now in here, PN junction diode, this is a diode basically, we will develop a diode here now. In diode, through a special technique, by doping impurities, two types of semiconductors are fabricated and called P-type and N-type semiconductors. You see, in semiconductors, doping means by inserting some impurities. Impurities डालने के बाद क्या होता है semiconductor में? Either it will be positively charged or it will be negatively charged. In somewhere free electrons will be there, somewhere holes will be there with a positive charge, holes will be there. So there are two separate semiconductors. हमने अलग-अलग तरीके से impurities डूप किया. And one we call it P type, another we call N type. N type में free electrons are there, P type में positive holes are there. Now these two we are going to join है, somewhere we both just आजू-बाजू में ये दोनों को रख के join कर देंगे. P type on left side has holes and negatively charged impure ions. Holes are majority charge carriers on P type. The majority charge are holes. Okay. N type on right side has free electrons and positively charged impurities ion. Electrons are majority charge carriers on N type. So electrons are the majority charge. Whereas the holes are positively charged. यह majority है होल का, यहाँ पे electrons का majority. These holes and electrons are mobile charges. These holes and electrons are mobile charges. They can move. The charges can move from here to here. These two semiconductors are joined through a thin layer to form a PN junction diode. So इधर को join करने के बाद ये जो ये जो सेमीकंडक्टर क्रिएट हुआ, दे आर बेसिकली, इट इज बेसिकली पीएन जंक्शन डायोड. Okay, this is called PN junction diode. This is one of the these basic semiconductor components. PN junction. Okay, let's see for the next. So what happens when these two you put close to to one, both are put closely and you join them. What happens? The free electrons from N type moves to the P type area. P type positive holes moves to the N type area. They along the junction, along the thin junction. Thin junction आजू बाजू में the charges move हो जाता है. This type of it takes this position. Okay, and by way of doing this movement of these electrons and holes, the current is generated in this region. After joining this recombination of these positive holes and negative electrons from the N type, so in this area the free charges are reduces, free movement of electrons and movement of positive holes reduces. So that's why it is called, in the area is called depletion region. यहाँ पे movement कम हो गया, but electric current is, electric field है, electric field there. So by joining this happens to the semiconductor. This is the characteristics of the P type and N type semiconductor. So holes from P region diffuses to N region and combines with free electrons of N region. Similarly, free electrons from N region diffuses मतलब jumps into P region and combines with the holes of P region. Some of the holes in P region and some of the free electrons in N region diffuses towards each other and recombine. However, total recombination does not occur because ये डिप्लेशन एरिया छोड़ के बाकी जो है उसमें there are still free electrons are there, still positive holes are there. That's why it is, however, total recombination does not occur. Because of recombination at the junction region, a depletion layer is formed and it is referred as space charge region. Okay, this area is called space charge region. An electric field is also generated in this space region, space charge region. For silicon PN junction, the potential is 0.75. You see that PN junction can be, if it is made from silicon, then potential difference will be 0.7 volt. If it is some other metal used, so potential difference will be something else. Now next is what we will do. PN junction is developed. Now what we are going to do with this? Okay. So what is happening now? What we will do, this PN junction, we will add some battery. Okay, we will add a battery here with positive side to the P side and negative terminal to the N side, N side. When a battery is connected to PN junction such that positive terminal of battery is connected to the P side and negative terminal is connected to the N side, it is called forward biased. So it is a forward biased PN junction. Okay, this is a forward biased PN junction because positive we have added to the P type and negative we have added to the N type. Now what happens? Let us see. When positive charge comes here, then holes moves from the positive terminal towards the junction because this is positive charge coming, this is the positive, so this move to the junction. Same way electrons also moves from this side towards the junction. Okay, from negative terminal से दूर जाके यहाँ आ जाएगा. So by the what will happen? Because of this pressure from the both side, this depletion layer will reduce. This depletion layer will reduce. ये तो इतना बड़ा था पहले, अभी इतना सा हो गया, छोटा हो गया. So depletion layer reduces. Width of the depletion layer reduces and more majority carriers diffuse across junction Finally, when the supplied voltage equals the potential barrier voltage, depletion barrier destroys and PN becomes a conductor. Now you see, if when you keep on supplying this, voltage difference is there. If it crosses the, suppose it is a semiconductor PN junction and voltage is crossing 0.7 volt, then what will happen? This will vanish. Depletion barrier will destroy, and this will become a conductor. It will become a conductor when voltages of the battery voltage is more than the 0.75 if it is a silicon PN type PN junction. If supply voltage increases further, it results in flow of current from P to N, and the current depends on the voltage of the battery. So if you keep on increasing the if you increase the voltage, now this is become a conductor. It is become a conductor, and current will flow from this to the conductor. So in forward junction, forward bias PN junction, if voltage is increase, this becomes a conductor and current flows through that conductor. Now it's the reverse bias. Reverse means क्या होता है इसमें? Just like forward, instead of P type, the positive terminal goes to the N type, and negative terminal goes to the P type. Okay, when a battery is connected to the PN junction, such that negative terminal of battery is connected to the P side and positive terminal is connected to the N side, it is reverse biased. Okay, reverse biased PN junction. PN junction diode. Okay, holes in P region moves towards the negative terminal, because the negative charge is there. So holes will move to the negative terminal. Hole means all positive charge will move the negative terminals. The same way negative regions moves towards the positive terminal. Negative जितना भी है, that will move to the positive terminal. This side. This is positive terminal. Majority carriers are drawn away from the junctions. What happens? So these all moves away from the junction. In forward bias we have seen this depletion layer reduced. यहाँ पे क्या हो रहा है? Depletion layer increase हो रहा है. Majority carriers are drawn away from the junction. The width of the depletion layer increases, and barrier potential increases. Resistance also increases. The PN becomes like a insulator. So what happens when this in reverse bias? We have seen forward bias, the PN junction becomes a conductor, but here in reverse bias it becomes a insulator, because depletion layer बड़ा हो जाता है. This process in reverse bias result in constant flow of current and is called reverse saturation current. But you see, there is always a small current will be there. Negligible current will be there. That there is called reverse saturation current. Okay, so this is the PN junction with reverse bias. Let's see the next. So, okay, and graphically we will see the characteristics of PN junction diode. If you draw a curve like this, x axis, y axis, x में हमने voltage रखा and y में current है, then we have seen in forward bias PN junction, when we supply the there is a voltage difference, then there is no current initially. Okay, there is negligible currents. So voltage increases, current is not there. But when voltage comes to a point, for example, we have seen that silicon semiconductor is 0.7 volt, then suddenly current increases, sharply increases. So characteristics of forward bias semiconductor can be shown like this. Voltage and current characteristics, VI current, this graph voltage is characteristic is graph of voltage applied to diode and current flowing through it. When voltage is 0, current is also 0 in the forward bias. Initial current is very small till external voltage crosses the barrier potential. For silicon, it is 0.7 volt. Above 0.7 volt, a small increase in voltage produces sharp increase in current. Okay, current both ज़्यादा हो गया. But in reverse bias, you see, reverse bias diode currents are very small in microampere. Currents are very small. But after voltage, after a particular voltage, that is called breakdown voltage, here also current increases rapidly. Okay. So forward biased, but it is a reverse. It is a reverse direction current flows. Okay, and this is a forward bias. This is a reverse bias. So we have seen the characteristics of PN junction. Now we will see the application of this characteristics of PN junction diode. इन फॉरवर्ड बाइज में उसको कैसे यूज़ किया जाता है, रिवर्स बाइज में उसको कैसे यूज होता है. विल सी दैट नेक्स्ट. So before that, let us see how it looks, PN junction. So symbol of diode is this, P and N, these two terminals, and symbolically it writes this, the anode and cathode. In a motherboard, you can see this symbol, the diode, symbol of diode. Now, Zener diode, this is the application of PN junction in forward bias case. In general, diode allows to flow current in forward direction. Zener diode is special purpose diode that flows current in reverse direction, but with a specific condition. You see the symbol is, that's why symbol is changed. In earlier, you have seen symbol is this vertical, the current flows this way only. But in Zener diode, current can flow this side also. That's why the symbol. So Zener diode is special purpose diode that flows current in the reverse direction, but with a specific condition on the breakdown voltage. Okay. So what I was telling, that if it is, when the voltage across the diode is in reverse bias increased, reverse current sharply increased, and it is called Zener effect. It is on breakdown voltage. You see, I have seen that. I think I should tell it again. In reverse bias, when Vz is the breakdown voltage, when it is increased, छोटा सा थोड़ा सा increase हो गया, this current suddenly increases. That is a Zener effect. That is Vz. When reverse voltage increase the breakdown voltage, Zener diode is act as a constant current source, but with a fixed Zener voltage. When this increase further, but voltage will come down again, but current will flow continuously. Since a fixed voltage mein high current will be there. So when reverse voltage increases the breakdown voltage, Zener diode act as a constant current source, but with a fixed Zener voltage. Zener diode is specified by its breakdown voltage, like 0.6 volt Zener diode or 0.8 volt Zener diode. उसको नाम है, हर एक Zener diode का नाम है. मतलब after 0.6 volt there will be current. After 0.8 volt there will be Zener diode, there will be constant flow of current. So depending on the which voltage, what is the what type of Zener diode we are using. So depending on that capacity of the breakdown voltage, their name or Zener diodes are named like that. Zener diode is used as a regulator circuit, and current circuit made to regulate the current. Zener diode is used. Okay, this is the application of PN junction in forward biasing. PN junction in forward bias radiates energy during recombination of holes and electrons around the junction. In general, radiation is in the form of energy. In light emitting diode, the radiation is in form of light. Materials such as gallium arsenide phosphide and gallium phosphide are used to radiate red, green or orange light. What type of material is used in your PN junction, depending on that the light will emit. If this for red, green and orange light, gallium arsenide phosphate and gallium phosphide are used. LEDs are used in electronic display, calculators, multimeters, telephone switch board and many more electronic circuits that we know. The uses of LEDs. LED works on low voltage 1 to 2 volt and low current 5 to 10 milliampere and consume less power. They are small size, light in weight and have long life. So this is the application of PN junction in forward biased. Okay, this is the other major application of PN semiconductors in to form transistors. Now, what is transistors? Transistors are joined of three semiconductors like NPN or PNP. You see, the हमने PN junction में क्या देखा था? The two semiconductors. Here we can see the three semiconductors. What is NPN or PNP? Both are there. Central semiconductor is called base with small size and weakly doped. Center में जो है उसको बोलते हैं base of the transistors. इस size में छोटा है बाकी दोनों से and weakly doped. Impurities are less. Then this side is called emitter. It emits electrons. Emitter semiconductor is moderate size and strongly doped. Okay, is moderate size and strongly doped. Collector, other side is called collector. Collector semiconductor is large in size and moderately doped. Okay. Emitter and collector region are same type. These are with the same type material. Same type material. Functions of emitter is to emit electrons into base, and base passes most of electrons to collector from base. So it passes, emitter means it passes electrons to this side. This passes electrons to the collector. Symbolically, it shows like this. Symbol of NPN. This is the base, this is the emitter, this is the collector. This is the base, this is emitter, this is the collector. You see, there is an arrow. This arrow shows that it is a NPN transistor, and this arrow is this side. Each emitter to base. It is PNP transistor. If you see open the again motherboard, you can see this type of components are there. They are transistors. It has three legs. One is the base, and one is emitter, one is collector. Now, why do you use these transistors? Now, you see, when there are two junction, so there are four possibility of biasing. The one can be, this side may be forward bias, this may be forward, this may be forward, this may be reverse bias, this may be reverse, and this may be forward, this may be reverse, and this also may be reverse biased. So there are four types of possibility there for biasing. Depending on that biasing, resistors are used. Four possible conditions of biasing of the two junction of transistors. These four possible regions are active region, they are called active region, saturation region, cut-off region and inverted region. Transistor can be used as a current amplifier in active region. Transistor is used as switch in saturation and cutoff region. Transistor is used to regulate power supply. Transistor is used in SMPS to convert AC inputs to regulate DC outputs. So these are the applications of transistors. Computer always needs DC input. So any input given to the computer from your source as AC, by using your rectifier and transistor, it is converted to regulated DC output it gives, and that goes to the computer motherboard. I think this is the last one. This is I see how much time is left with us. Okay, we finish it. This is called logic families. Now see, there are so many logic gates are there. These are combined together. The small circuits are developed. Hundreds of circuits are integrated in a small chip. And when the hundreds of chips, circuits or gates, logic gates are integrated, they are called small scale integration circuit. Then if the number of gates, logic gates are in terms of 100, they are called MSI, medium scale integration. Then called large scale integration, in terms of 1000. So then ICs comes, integrated circuits. That is, they are called integrated circuits. There are two technologies to manufacture ICs. ICs called integrated circuits. Integrations are at different level, like SSI, small scale integration, medium scale integration, and large scale integration, depending on how many components are integrated. Okay. The technologies are bipolar and unipolar, or MOS, metal oxide semiconductor. Accordingly, the two logic families are there. You see, one is bipolar, one is unipolar. In bipolar में क्या है? Bipolar has three basic families: DTL, TTL, and ECL. DTL means diode transistor logic, then transistor logic, then emitter coupled logic. These are the bipolar semiconductors. Then MOS is there. There is a second unipolar. Their basic families are P-type MOS, N-type MOS, and complementary MOS or composite MOS. The second category. The parameters of these two logic families are mentioned in the side table. You see what happens. All these components, electronics components, has that own characteristics. That depends on this. Depending on the characteristics, they are categorized, and their performance depends on these categories. For example, parameters are propagation delay. You see, if you think of a AND gate, you give an input, output comes. Now what is the time it takes? Propagation time कितना है? For TTL circuit, it is 10 nanosecond. CMOS logic, it is 15 to 300 nanosecond. So it is more. Time in propagation delay is more in CMOS logic. Similarly, power dissipation, then power supply, how much power supply it takes, the package density, fan out. Fan out means when one input is given to your gate, that output can be used in other gates. So how many gates you can put in single line? That is called fan out. Sensitivity to high voltage, noise generation, how much noise it generates. So CMOS noise generation is low, and TTL loss generation is high. So these are the characteristics of your components, electronic components. And so I've seen that there are two families are there. One is bipolar family, one is unipolar family. Okay, let's see the next. So I think this is the ends. This ends your study of components and circuits. That I told him initially that all the physics behind this, the physics behind this electronics component will be studied in detail in your class 12 computer science paper 2. Okay, we have discussed only the basic concept of your electronic components. Okay, thank you very much. Take care. I'll stop here now. And we have now only one chapter left. That is, I think, the chapter number 9. That is peripherals devices. I will take that in the next class, next session. Okay, bye. Take care.